This video will be about geometry in the coordinate plane. So when we say coordinate plane, it's this graph setup where the horizontal line is always the x-axis and the vertical line is always the y-axis. And if we're going to graph a coordinate, they always write it in alphabetical, x first, then y. So if we were to say 2, 3, we start counting from the center, which is called the origin, and we go in the x direction first. We travel along the x-axis 2 spaces, and then y direction second, so then up 1, 2, 3 spaces. So that's the coordinate 2, 3. If we had negative 5, 0, negative 5 is 5 spaces to the left, and then 0 means don't go up or down. So that would be the coordinate negative 5, 0. So when you are using the coordinate plane, often they'll ask you to find the midpoint, the slope, or the distance. So let's start with the midpoint. So the formula for a midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. This is not included on the formula sheet, so it's one you need to have memorized. So when we look at the graph, we need to identify, well, what's this actual coordinate first before we can even try to use the midpoint formula. So from the center, we count, right, 1, 2, 3, 4, 5, 6 spaces. So 6, comma, and then up 1 space. So 6, 1. Then back to the center to count to the other point on this line. We go 1, 2, 3, 4, 5, 6. And we went left 6, so negative 6, comma, 1, 2, 3, 4, 5, 6, up 6. So we have two sets of coordinates. They're both using x and y, because every coordinate starts with x and then has y. And the way to distinguish them is to say, well, we're going to call this one our first point. So this would be x1 and y1. And this will be our second point, so x2 and y2. Now we can plug them into this formula. x1 is negative 6 plus x2, the x value from the second point, that's 6. Divided by 2. We can plug in the y. y1 is 6, and y2 is 1. So then we actually simplify this. When you're working with a fraction, we do have to add these together first before we divide. So negative 6 plus 6 is 0, and 6 plus 1 is 7. 0 divided by 2 is 0. And then 7 over 2, the answer could be left as the fraction 7 over 2. That is as simplified as that fraction can be. Or they could divide and get a decimal. 7 divided by 2 is 3.5. So 0, 3.5 is the midpoint. And if we go draw that in, 0 first means don't go left or right, just go up 3.5. And that looks very accurate to our line. What we found for the midpoint makes sense and looks like it is the correct midpoint. So let's take this same line and find the slope. So we had a coordinate that was 6, 1, and we had a coordinate that was negative 6, 6. And we said, well, this is the first point, so this is x1, y1, and this is the second point, so this is x2, y2. So the formula for slope, which is often represented with the letter m, is y2 minus y1 divided by x2 minus x1. So even though the formula is different, the concept is the same as midpoint. Everywhere we see a variable, we're going to replace with the corresponding number. So y2 corresponds to 1. We'd say 1 minus y1 is 6 over x2 is 6 minus x1 is negative 6. So notice this does come out minus minus. We have a minus from the formula itself. And then the 6 also happened to be negative. So when you have a minus minus, that actually changes those two symbols into one plus symbol. When you have negative directly to negative, that's actually adding. So we do 1 minus 6 is negative 5. 6 plus 6 is 12. Often the slope is left as a fraction. We do need to check and make sure it is simplified. So we ask if there is anything that divides into 5 and also into 12. Well, into 5, the only thing that divides into 5 is 5 itself, but if you try 12 divided by 5, that comes out as a decimal. So this does not simplify anymore. Negative 5 over 12 would be your final answer. The last formula we can use is the distance formula. So same line again. 6, 1, negative 6, 6. The distance formula, which is usually represented with the letter D, is the square root of parenthesis x2 minus x1 squared plus parenthesis again y2 minus y1 squared. Same concept, we take our numbers and plug them into their corresponding variables. We do know that this was x1, y1, the x and y value of the first point, and x2, y2, the x and y value of the second point. So we go replace. x2 is 6, minus x1 is negative 6, y2 is 1, minus y1 is 6. So now we simplify. Same idea here, negative next to a negative is really 1 plus sign. And order of operations says we need to do what's in the parentheses first. So we do the 6 plus 6, which is 12, and the 1 minus 6, which is negative 5. Then order of operations says to square, so use the exponents. 12 squared means to do 12 times 12. We are not doing 12 times 2. Squared means take this number and multiply it by itself. So that is 144. Negative 5 squared means do negative 5 times negative 5, which is positive 25. You do have to watch out if you plug this into a calculator. If you do not include the parentheses with the exponents and the numbers negative, the calculator is going to tell you it's negative 25 when the answer is positive 25. So you do want to make sure to include the parentheses in your calculator. Then we add together. 144 plus 25 is 169. And then we square root. The square root of 169 is 13. So let's work through some practice problems where it's going to be a little more difficult. They're going to include some shapes instead of just saying what's the midpoint. So if P is the midpoint of WY, so notice they don't even have that labeled yet. So P is the midpoint of WY. It's halfway between the letter W and Y. And Q is the midpoint of XY. What is the slope of P to Q? So this is actually asking us to do a couple of things. First, find the midpoint P, then find the midpoint Q, then use those to find slope. So we have a couple of steps. So first we need to identify the coordinates. W, counting from the center, is left 1, 2, 3, 4 spaces, and up 2. So W is negative 4, 2. Y is, counting from the center, right 1, 2, and up 1. And X, we don't go left or right, so 0 and up 1, 2, 3, 4, 5, 6 spaces. So let's find P first. It's the midpoint of WY, so we are using x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. x2 being the x-coordinate of the second point. So we go from W to Y. The x value of Y is 2. The x1 is the x-coordinate of the first point, so -4, divided by 2. y2 is the y value of the second point, so 1, plus the y value of the first point, 2, divided by 2. And it's always divided by 2 on the bottom here. So 2 plus -4 is -2. 1 plus 2 is 3. And then if we divide, -2 divided by 2 is -1. 3 divided by 2 gives us a decimal, 1.5. Now let's find Q. That is also a midpoint, but of xy. So from x to y, the x-coordinate of the second point is 2. The x-coordinate of the first point is 0. The y-coordinate of the second point is 1, and the y-coordinate of the first point is 6. We add the numerators first. 2 plus 0 is 2, 1 plus 6 is 7, and then we divide and get 1, 3.5. Again, we're getting a decimal. So now we want the slope from P to Q. Now we're going to use the slope formula. Slope formula was y2 minus y1 over x2 minus x1. But now we're using the P and Q coordinates. So our first point is P, our second point is Q. y2 is 3.5, y1 is 1.5, over x2 is 1, and x1 is -1. We do our numerator first. 3.5 minus 1.5 is 2. -1 with a negative symbol in front of it all changes to plus. So 1 plus 1 is also 2. And then 2 divided by 2 is a slope of 1. So our final answer is 1. We had a lot of in-between steps, but our final answer is the slope of PQ, which is 1. So let's look at this next problem. We have an A and a B and a C on the coordinate plane. Where should coordinate D be placed to make parallelogram ABCD? So we've talked about parallelograms and how a parallelogram has two sides that are parallel and congruent. The top to bottom is parallel and congruent. So we need to put coordinate D on here so that we get two sides that end up being parallel and congruent when we go across from each other. So you can kind of eyeball it and see where about it should be. We're thinking in this region somewhere we'll make this somewhat parallelogramish. To make it a little more exact, you can actually just count from point to point and do that same order. So from B to C, so not from the center necessarily, but starting at B, I go down 1, 2, 3 spaces and left 1, 2. If we do that same amount from A, we actually end up with the same slope. Slope is how much you are counting down and over, so if we actually count it out, then we don't have to go in and use the entire formula. So we count down 1, 2, 3 spaces, left 1, 2. You see when we connect, it makes a pretty good parallelogram. One last problem. Let's say we have this triangle, and they want to know what kind of triangle is this. We had our side lengths, so scalene, isosceles, or equilateral. We had our angle measures, acute, obtuse, right, or equiangular. So looking at this shape, it kind of looks like it could be a right triangle with the right angle here. We can check that by checking the slope. Two slopes are perpendicular, so they meet at a 90-degree angle, if they are opposite reciprocals. So if we had a slope of -1/2, we switch it to positive and flip it upside down, and those two slopes are opposite reciprocals. So we are going to have to find the slope, and so we need to identify some of these coordinates. If we count left, 1, 2, 3, 4, 5, that's -5, did not go up or down, so 0. We count up, 1, 2, 3, 4, 0, 4. We count right, 1, 2, 3, 4, and down 1, so 4, -1. So we're going to find the slope from the -5, 0 to the 0, 4. Slope is y2 minus y1 over x2 minus x1. Our y-coordinate of our second point is 4, minus our y-coordinate of our first point, 0, over x-coordinate, 0, minus x-coordinate, -5. It gives us 4 over negative next to a negative changes to plus, so positive 4 over 5. So now we're going to check the slope from 0, 4 to 4, -1. Same formula, y-coordinate of the second point is -1, minus y-coordinate of the first point is 4, over y-coordinate of the x-coordinate of the second point, 4, minus x-coordinate of the first point, 0. -1 minus 4 is -5, 4 minus 0 is 4. So 4 over 5, if we flip that upside down, gives us 5 over 4. That's doing the reciprocal. And if we change the sign from positive to negative, that's getting the opposite. So 4 over 5 and -5 over 4 are perpendicular, which means, yes, this is a right angle. That means it's right, can't be acute, obtuse, or equiangular. And if something's equiangular, that's the only way it can be equilateral. So we actually do get to cross off equilateral. So now we have to decide between scalene and isosceles. Scalene means all three sides are different. Isosceles means two sides are the same. On an isosceles triangle, the hypotenuse cannot be the two sides that are the same, though. So hypotenuse is across from the right angle. We're only going to have to check the distance on, I'm going to call this side A and side B. So we're going to check the distance of side A and check the distance of side B. Distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. Let's do side A first. So we're using -5, 0 and 0, 4. x2 is 0 minus x1 is -5 squared plus y2 is 4 minus y1 is 0. 0 minus minus is plus, so 0 plus 5 is 5. And 4 minus 0 is 4. 5 squared is 25, and 4 squared is 16. 25 plus 16 is 41. And the square root of 41 is going to be a weird decimal. So it's approximately 6.403. Now we have to check side B. So the 0, 4 and the 4, -1. Running out of room. So x2 is 4 minus x1 is 0. y2 is -1 minus y1 is 4. 4 minus 0 is 4. -1 minus 4 is -5. 4 squared is 16, and -5 squared is 25. They had to be square root of 41 again, which is approximately 6.403. So these are congruent. Those two sides are congruent, which means this has to be isosceles. So this triangle is an isosceles right triangle.